All right, today we're on page 41 in your textbook going over solving compound and absolute value inequalities. All right, notice again your highlighted terms in your book for glossary purposes. So what we're dealing with today is we're looking at graphing more than one inequality. Compound meaning two inequalities for us, okay? And then we'll deal with absolute value inequalities in a second. So I'm going to look at this right here. So let's say that we had two things. We had x is greater than or equal to -4. We've already looked at in chapter 1 at graphing that. And let's also look at x is less than 3. And we're going to graph both of these on the same number line. All right? So this is what we're looking at today, kind of like getting two answers. And then the graph is going to tell a little bit of a story. So I'm just going to go ahead and graph this. This isn't even example 1 yet. This is above example 1. So we're going to graph x is greater than or equal to -4. And x is less than 3. Remember, gator mouth points to the bigger thing. So if I'm thinking about a number line right here, all right, and I'm at 0, remember we're graphing these just on a number line right now. Going to come out to -4, -1, -2, -3, -4, and we're going to go up to 3. 1, 2, 3. There's 3 right there. You can label all of them. Just make sure you're consistent in how you do it, all right, as you're dealing with that. So basically we're saying, hey, out here at -4, we need to get greater than -4. Remember on the number line, as you move right, that's greater than. And we're going to go x is less than 3. So from 3, we're going to get smaller than 3. So you can see these are working towards each other, all right? Now at -4, I'm going to put a solid dot because I have an equal sign. At 3, I don't have an equal sign, so I'm going to put an open dot. And remember, from -4, greater than that is that way. Less than 3 is that way, and you can see the two graphs meet. So we can show on one graph basically two different solutions where we have a value that x is greater than or equal to -4 and x is less than 3. Any answer in between here, including -4, would be a solution to both of those. All right, so you could plug in those x's and it would work, and that's what we're dealing with. So let's jump down to example 1. All right, and it says this: to solve 8 is less than 3y minus 7 is less than or equal to 23. Now, your book shows you two different ways to solve this. I solve it like method 1. That's my personal preference. If you want to learn how to do method 2, copy it down from page 41 right there. All right. So when I see this and I have one variable in here, the 3y minus 7 is talking to both inequalities. And so I'm going to rewrite it. This is called an and compound inequality, all right, because it's saying 3y minus 7 is greater than 8 and 3y minus 7 is less than or equal to 23. So we're going to write out what I just said. Now pay attention to the gator mouth. So here's my first one. I'm going to have 3y minus 7, and you see how the gator mouth is towards the y? I'm going to leave it towards the y. So 3y minus 7 is greater than 8. That takes care of that part of the inequality. I just kind of rewrote it and put the variable on the left. And then the other part I need to take care of is that. I can just write in between here, and 3y minus 7 is less than or equal to 23. All right? So that's what we're doing. So it says solve this, and then we're going to graph it on a number line. Well, I just need to go solve for y in both of these. How do we solve? We do PEMDAS backwards. Remember, we're not putting together. We're taking apart, or we're solving for a variable. PEMDAS backwards. All right, here we go. That means I need to move this subtraction. So I add 7 to both sides. Those 7's cancel out. I get that 3y is greater than 15. I'm not going to have to flip this sign because the coefficient with y isn't negative. All I need to do is divide by 3. Remember, we divide by the sign that's there. We don't flip those signs. The way you cancel out addition and subtraction is different than the way you divide. We want that to reduce to 1. So 3 divided by 3 is 1. So I'm left with, on this side, y is greater than 15 divided by 3 is 5. So there's 1. Y is greater than 5. We're going to graph that in a second. But remember, we're dealing with an and inequality, and we know that because of the way it was written. All right, so here we go. Solve for y over here in this second one. I'm going to add 7 to both sides. I get 3y is less than or equal to 30. Again, we're not going to have to flip the inequality. Our coefficient with y is not negative, so I'm just going to divide by 3, and I get that y is less than or equal to 10. So basically what I have is this. From 5, my graph is getting bigger. From 10, my graph is getting smaller. So as we go put this on a number line, let's say that's 0, 1, 2, 3, 4. There's 5, 6, 7, 8, 9. There's 10. All right, at 5, it's an open dot because I don't have an equal sign. At 10, it's a closed dot because I do have an equal sign. It says y is greater than 5, so that part of the graph is going this way. Y is less than or equal to 10, so that part of the graph is going left, and there's our connection, okay? Open dot at 5, closed dot at 10. There's your solutions, there's your graph, okay? That's how we do that. Compound inequalities that we call AND inequalities, all right? Flip the page. Let's go look at OR inequalities. These, in my opinion, set up a little bit simpler, all right? So I'm on example 2 right here, towards the bottom of page 42. Example 2 says this, that we've got k plus 6 is less than negative 4, or 3k is greater than or equal to 14. It's already split for us. An OR inequality will generally be written this way. So now we're just going to go get k by itself on both sides, and we're going to graph it. All right, so here we go, solving for k. We're going to do PEMDAS backwards. I got to get rid of the addition first. Minus 6 on both sides. I get k is less than negative 10. Or we come over here and we divide by 3 to get k by itself. And I get that k is greater than or equal to 14/3. And you're like, how am I going to graph that? Well, we need to find what whole number or what whole numbers that this fraction fits between. All right, so let's go look at this graph. So we've got a little bit of space here. So I'm at 0. Let me count my 2's. Negative 2, negative 4, negative 6, negative 8, negative 10. I know right now if k is less than negative 10, at negative 10 I can put a closed dot. Where do the numbers get smaller than negative 10? To the left. So I'm going to draw this thing and already have a good idea what's going on here. So we're drawing that graph to the left. All the values fit that. All right, now we need to go to 14/3. Let's say we're not good at that. Well, let's let the calculator be good at it. All right, I'm going to go in and do 14 divided by 3. Oh, and we're going to see that that's between 4 and 5. It's really 4 2/3 as a mixed number. So let's do that. Now, here on the right side, I'm going to count by 1. It doesn't matter. 1, 2, 3, there's 4, there's 5. So 2/3 of the way between here, it's going to be closed dot because it's an equal sign. And you know what? I'm going to come right here and put, hey, that's 14/3. So that I know that you know what you're talking about. And this says k's are getting bigger than that. So bigger than 14/3 would be to the right on the number line, and that's what my graph looks like. Most of the time, an AND graph up here will go towards each other, and an OR graph will go away from each other. Now, that's not a 100% deal, but that works most of the time. Here's kind of what the words mean. If it's an AND inequality, it has to be true for both statements. Y needed to be greater than 5 here, and y needs to be less than or equal to 10. For it to be true, it's got to be both. For this one to work, for it to be OR, it only has to work for one of them. So if k is less than negative 10, it does work for this one. It doesn't work for this one, but it still satisfies the inequality because we just need it to, that's what OR means. It's got to be one or the other. Same thing here. As long as it's greater than 14/3, it fits, it works for the entire set because it fit this one, all right? So that's what's going on there. All right, so last thing here now, we're going to deal with absolute value inequalities, all right? So I'm going to turn my page. We're on page 43 now, example 3. Example 3, absolute value. It says solve each inequality and then graph it. So here's what we got. First one, absolute value of x is less than 3. Now we're going to have two different graphs here. It may be and, it may be or, we'll deal with it. It has a lot to do with this sign. If it's less than, it usually ends up being an and. Here in a second, when it's greater than, it ends up being an or, but we'll deal with it. So here's how you set it up. Your first one is just going to be x, and then you're going to write what's there. Just write x is less than 3. Remember, absolute value measures distance from 0, so we've got two things that can, it can be positive or negative. Now, to take care of the negatives, here's what I do. All right, this one's going to be an and I'm going to go x is greater than negative 3. What did I do? I flipped the sign, and I flipped the sign. That's the trick. So when it's a less than in your absolute value, it's going to be an and. We're thinking this graph's probably going towards each other. But now we're going to go graph this. So I did x is less than 3. That takes care of that side, or kind of the positive part of it. Dealing with the negative part, I flip this sign and I flip this sign. X is greater than negative 3. All right, here we go. Let's graph it. So be careful. There's 0, 1, 2, there's 3. -1, -2, there's -3. So at 3, I'm putting an open dot because it was just less than. At -3, I'm putting an open dot because it was just greater than. Less than 3, greater than -3 goes between each other. There is my AND graph for my inequality. Absolute value inequality, it works like an AND when it starts with less than. Let me jump down. That was part A. Let's look at part B. Absolute value of x is greater than 5. When it's greater than, so again up here, this means and. When it's greater than, it's going to mean or. All right, let's deal with it. Here we go. So that means I have x is greater than 5 or x is less than -5. That's where the flip comes. Flip the sign, flip the sign. If this would have been negative, we would have flipped it. Now you got to be careful because generally we're trying to get a positive answer, but that's something we'll deal with later. All right, here we go. So x is greater than 5 or x is less than -5. There's 0, 1, 2, 3, 4, 5 is getting an open dot. 0, -1, -2, -3, -4. There's -5. It's getting an open dot because they were both just less than or greater than. There was no equal sign. All right, so x is greater than 5. Greater than 5 is to the right, so there goes that graph. Less than -5 goes to the left, and there's that. So all these solutions are greater than 5 or less than -5. And remember, it's not including those points because there wasn't an equal sign. So 5 and -5 don't count for this one. All right, let's jump to one we're going to do a little bit of work on. I'm going to wrap this up for the day. Example 4 on page 44. All right, again, we're solving this absolute value inequality, and then we're going to graph. So example 4 says to solve the absolute value of 6y minus 5, and that's greater than or equal to 13. We're thinking greater than. I'm thinking it's going to be an or graph. Obviously, with an equal sign, we're going to have closed-in dots on our graph. So here's how we set up the or. 6y minus 5 is greater than or equal to 13. The first one, just drop the absolute value bars. Then write or. Again, it's or because it is greater than. All right, the equal sign's just there. And this time I'm going to go 6y minus 5. The stuff inside the absolute value doesn't change, but then the sign flips, and then the answer, or the whatever that other solution flips. Since it was positive 13, it becomes negative 13. All right, let's solve both of these. So I got to get rid of subtraction before multiplication. So I add 5 to both sides. I get 6y is greater than or equal to 18. Remember, -5 and +5 cancel out. To get rid of multiplication, we divide by 6. So one of my answers is y is greater than or equal to 3. Or, we do it on the other side, same thing. I add 5 to both sides, plus 5. I get that 6y is less than or equal to -8. -13 plus 5 is -8. Again, remember, our 5's canceled out. I divide by 6. A little bit of a fraction here. No big deal, but this reduces, and this is y is less than or equal to -4/3. Now, if you're not good at that, go to your calculator, do -8 divided by 6. All right, hit enter, and then math enter. Takes it to -4/3 right there for you. All right, so let's go graph this. We should be all right. So I'm going greater than 3, so there's 0, there's 1, there's 2, there's 3. It's a closed dot. This is an or graph, so I think the graph's going away from each other. So that's going to the right. There's greater than 3. Now, -4/3 is between -1 and -2. If you're not good at that, go back and look at what the fraction was. It was -1.33333. That's between -1 and -2. There's -1, there's -2. All right? I am a third of the way inside of -1. It's a closed dot, so it's not quite halfway. I'm going to come here and put -4/3 and draw a little arrow so that I know that you know what you're talking about. Our y's or our variable is getting smaller than that. Smaller on the number line is to the left. There it goes. There's our graph. All right, there's our graph. All because we had a greater than. I'm going to do one more that's a less than and make sure we're good. So go to guided practice 4B right here, almost right in the middle of page 44. So this is 4B, guided practice. Here we go. 5z plus 2, the absolute value of that is less than or equal to 17. So now I've got a less than. I'm thinking, hey, this is probably an and inequality. So here we go. 5z plus 2 is less than or equal to 17. Just write what's there and drop the absolute value bars. All right? And write and now we flip this stuff. So I've still got 5z plus 2, but now it's greater than or equal to negative 17. I got to flip the sign and flip the sign. Do some math. Minus 2 minus 2, 5z less than or equal to 15. Divide by 5, and we get that z is less than or equal to 3. Sorry, running out of room down there. Okay, same thing over here. Get rid of the addition first. We're doing PEMDAS backwards. I get that 5z is greater than or equal to negative 19. This isn't going to be a whole number. That's okay. We divide by 5, and I get that z is greater than or equal to negative 19 over 5. That doesn't reduce. Now, if you want to know where that shows up on the graph, do negative 19 divided by 5. Between negative 3 and negative 4, real close to negative 4. Negative 3.8 is what that is. All right, so I'm going to come up here to graph this. Again, I was running out of room. Sorry about that. So here we go. So I know there's 0 right there. I know that z is less than or equal to 3. So there's 3, and I put my closed dot because it's less than or equal to. Now, we just said that negative 19 fifths was negative 3.8. So negative 1, negative 2, negative 3, negative 4. All right? It's a closed dot because it's an equal sign, and it was real close to negative 4. So that was, again, negative 19 over 5 right there. Okay? That's negative 19 over 5. Which way is the graph going? From 3, it says less than, so I'm going to the left. From negative 19 fifths, it's greater than, so I'm going to the right, and there's our OR graph. It's exactly what our AND graph. It's exactly what we thought it was going to be, because we have a less than sign, and graphs generally go towards each other. All right? Quite a few notes there, but that's some good stuff and stuff that'll help you when it's time to take a test over all this. Thank you for your attention. Make sure you're copying down everything into your notes like you're seeing it. If you have questions, go back to the YouTube video and watch it, or go in the textbook. You can look at those examples, and obviously you can come ask me for help.